So this video lesson is a review of writing equations from word problems, one of the things that we had done in class but aren't included in any of the video lessons that we did. So a quick review of the process that we're going to use in solving the problem, and that is first to identify the variable. That is, what is the unknown, what is it that we're looking for, because if we can identify what we're looking for, then we have a good idea the sorts of things you might need to do to find it. Secondly, we want to describe what's happening in words, that is, write a verbal model. Now, it's important when we say describe what is happening in words, we are not saying describe how to solve it, because a problem in its context never leads us directly to the solution. It doesn't describe the process for solving it, it describes something happening. And we'll spend a lot of the video here as we go through the first 2 or 3 example problems, talking about how to determine what's going on in the scenario. And finally, once you have that, you substitute the variable in the numbers you know, and then here in the process is where you solve. So let's take a look at an example problem here. We've got the process over to the left, and this is what you'll see. This kind of screen is what you'll see for the rest of the video. So first, we are going to say that we're trying to raise money to adopt an animal. You decide to sell cookies for $2.50 a piece. How many cookies do you need to sell to raise $50? Well, first, it's pretty obvious from this question that our variable is going to be how many cookies do you need to sell. So x, let's say, for number 1, x equals cookies sold. So that's what it is that we're looking for. Now we want to write this equation in a verbal model. What's going on? Well, on one hand, we have the total amount of money that we want to make, and we have the amount of money that you make from cookies. So we want to make $50, and from cookies we earn $2.50 for every cookie that we sell, and our number of cookies that we sell is x. So our verbal model is actually the amount of money we want is going to be equal to the amount of money that we sell from cookies. That's what we want to happen. We want to make $50, and we make $2.50 per cookie, so we have 250 equals 250 times x. Now we solve, divide by 250 on each side, and get 20 is equal to x. You need to sell 20 cookies to make $50. Let's take a look at an equation that's a little bit more complicated now. So we're taking a trip that's 224 miles long. Let's draw a number line here for us to understand it. We're going to start over on the right, sort of backwards from how a number line goes. This entire thing is 224 miles. We've already gone 59. And we're going to split the rest of it into groups of 55. So we plan to cover 55 miles every hour, so the rest of it is going to be grouped into 55-mile segments. How many hours will it take to get there? So our variable then, what we're looking for is x equals hours to arrive. That's what we're looking at. And now we get to the more difficult part of what is this scenario actually describing? Well, there are 2 things that are going on here, and this is why we drew the number line. The first thing that's going on is we have our total distance. It's the distance that we want to go. Now, on a road trip, you may in the middle of the road trip think, well, I've gone so many miles, and therefore how many miles do I have to go? But when you're planning the road trip or you're talking about the trip itself, you don't think about small sets of miles being taken away from the total distance. You think about the total distance. And so the total distance is the amount that you've already traveled plus the miles left. So the amount that you've gone plus the miles that you have left to go. Your total distance then is 224. You've already gone 59 miles, and for the miles left, you're going to go 55 miles an hour for every hour. And this is what we get for sort of use a mini distance equals rate times time. Our rate equals 55 hours or 55 miles per hour, and x is our time left. Let's scroll down here so we can solve this equation now. Subtract 59 from each side. Over here we have 55x. And 224 minus 59 is going to be 165. Divide both sides by 55. And get 3 hours is equal to x. So now we have 4 more problems left to go. I'm going to show you one at a time. Go ahead and pause the video when we get to each one. Work through it using that 3-step model. Come back when you're finished working through it and solving it, and we will discuss how to set it up, what the variable is, what the verbal model is, how to substitute, and how to solve it. So for this one, James typing a paper, go ahead and pause the video now. So the unknown here is how long will it take him to finish the paper? So x equals time remaining. Now, his paper is 924 minutes long. So the total length of the paper is going to be the amount of words he's already finished plus the amount of words that he has remaining. So the total length of the paper is 924 words. He's already finished 168, and we're not sure entirely how many words he has remaining, but we know he's going to type 42 words every minute for x minutes. So the number of words that he'll type from now on are 42 words a minute times x minutes. So this is the equation that we're going to solve. Total length equals the amount finished plus the amount remaining. Now if we subtract 168 from both sides, that will cancel. Do the math here, that is a 6. 756 is equal to 42x. Divide both sides by 42. That is here. We will have an x left on the left-hand side. And when we do the actual division for 756 divided by 42, we end up with 18. So 18 minutes is how much time he has remaining. So the next problem, problem number 4, go ahead and pause the video, figure out this one, and come back and we'll discuss it. So here we want to know how many brownies we have to bake in order to make a certain amount of profit. So our unknown is going to be the amount of brownies we need to sell. X equals brownies sold. We also know that we have a few different things we need to worry about. So we're interested in making $110 in profit. So the amount of profit that we make in any case is going to be the total amount of money that we take in minus whatever money we have to spend. So in this case, the money that we take in is $3.50 per brownie, and the money that we spend is $30. The profit that we want to make is 110. So the amount of money we take in for the brownies, 350 times x, minus the $30 we've spent, has to be equal to 110. Now we add that 30 back in. So we need to make $140 from the brownies, which is 350 times x. Divide that by 350 to solve it. And we get that, sorry, not 20, 40 is the number of brownies that we need to sell. So we need to sell 40 brownies. Last question for you to work on your own. Spend $70 one week. You make $70 one week mowing lawns. Earn $10 for every lawn you mow and spend $20 on gas. How many lawns did you have to mow to make $70 in 1 week? Go ahead and pause the video, come back, and we will go over it. So our question, how many lawns do you have to mow, is going to give us the clue that our variable needs to be the number of lawns that we mow. Now again, we have the profit, which is what we make after that, is equal to the amount of money that we make, the overall money that we make, or the money that we take in, minus the money that we spend. So $70, which was the amount that we made, has to be equal to $10 per lawn, so 10 times X, minus the $20 we spent on gas. Add the $20 back in, get 90 equals 10X, and then divide both sides by 10 to get that 9 lawns is the amount that you need to sell, or rather the amount that you need to mow. So 3 steps: identify what it is that is your unknown, describe what's happening, not in terms of solving it, but in terms of what's actually going on. How do you make the $70 you want? How do you finish the trip of 924 miles? And finally, substitute the variable and the numbers you know and solve the equation.